Hi everybody, my name is Mark and welcome to the second video in my practical networking series where I talk about VLANs. So just a little bit of a refresher, my practical networking series is basically designed to kind of take some concepts of networking and really break them down into something really easy to understand. So that way, whether or not you are somebody who's just a hobbyist and you're trying to just understand some concepts, or you're studying for your Network Plus or your CCNA, and you just want another high level explanation to really get the fundamentals and kind of see them in action, then this series is for you. So let's kind of delve right in and really kind of talk about what VLANs are at a high level. Keep it really, hopefully easy to understand and really demonstrate in a practical way like how you would kind of use these. So what is a VLAN? A VLAN is a virtual local area network. So this is how you would logically separate physical networks. So in this diagram, we have four different computers and they are all connected to the same switch. If we were to create two different VLANs on this switch and divide up this network, both sides of this could not communicate to each other. So the computers in the red VLAN 10 side could not ping or communicate with computers in the green VLAN 20 side. But if you are in that VLAN 10, you could communicate and ping any other device as long as it's in that same VLAN. So, like, why would you want to do that? Well, you'd want to do this if you wanted to separate traffic. So, say red is accounting and green is HR, and you don't want them to have access to each other's data. This is a great way to do that. Or, say one is your guest network and one is your internal network. You could do that. Or, say one is a vendor network and the other one is whatever your production network is. You'd want to keep all that traffic kind of separated. So security is a big driver for why you'd want to do this, as well as performance. So a lot of host devices will send broadcast traffic all the time. Broadcast traffic, albeit small, can create penalty and noise in our network. So you could keep, each of your host devices from having to process all that extra broadcast traffic, and as well as for like organization and design. So you want to design your network very intentionally. So maybe you want, different classifications of devices to have different networks. Well, you can have a network or a subnet attached to that VLAN. So, you can have your VLANs kind of correspond with whatever IP addressing scheme you have. So there's a lot of different reasons why you'd want to utilize VLANs. So just like a real quick under the hood as far as like how a VLAN works. So your computer, your host, is going to send traffic to whatever switch it's connected to. And that switch will have a configuration to basically say, whatever traffic I receive on this interface, in this case, this computer will be connected interface FA015, Fast Ethernet 015, go ahead and tag it with VLAN 10. And it's a really quick configuration. So like if you're running a Cisco device, if you do a CompT interface Fast Ethernet 015, switch port mode access VLAN 10. That's it. So if this were a frame down at the bottom, so destination MAC, source MAC, and 802.1q, which is the IEEE protocol, as traffic is received on the interface, it's just going to add that tag in there. It's going to tag it with VLAN 10 and forward it on. So as a switch switches frames and switches traffic, it's going to make sure that these devices on different VLANs cannot see each other's traffic. And that's really it. So computer connected to an interface, and that VLAN configuration exists on that upstream interface that computer is connected to. So this computer doesn't even know it's on that VLAN. The switch is going to be what designates and tags that traffic. Does that make sense? Let's kind of see it in action. So let's jump over to a quick practical where we are going to configure some VLANs. So I'm going to have a really basic topology. And the first thing I'm going to do is let's see if all these computers can ping each other. When it starts, they're all going to be on the default VLAN. So default VLAN is just unconfigured. Then we're going to create VLANs 10 and 20 on each switch. So here on the right hand side, that's all the configuration that you would even need. It's super simple to do. So we're going to create that. And I kind of hinted each switch. I'm going to have a little bit of a stretch demonstration here. We're going to assign each interface to the corresponding VLAN because, again, that configuration goes on the interface. And then we're going to go ahead and test pings. So let's jump in. So a little bit of a jump cut because my OBS stopped froze on screen record, but yeah, right here we have a very, very simple network topology. So we have a unconfigured switch with 3 client devices hanging off of it. So we have laptop, 0, 1, and 2, 1, 2, and 3, however you want to, number them out, but they're all configured on the same subnet and the same network. Usually you may not want to do this when you do separate VLANs, but just for the sake of being able to visually see what they do, we're going to go ahead and do that. And though they say one's going to be in default, one's going to be in VLAN 10, and one's VLAN 20, they have not been configured and put in those VLANs quite yet. So we want to kind of show that process. So real quick, right now, this is the CLI for the that first laptop on the left, the .10. Let's just make sure it can ping all of its neighbors because, again, this upstream switch is unconfigured. So all of these should be able to ping and talk to each other, which they can. So cool. Exactly default VLAN, everything works, everything pings. So let's log into this upstream switch. So this is the switch 0 and it's currently unconfigured. So let's just verify that. Let's get into enable mode by typing en and let's do a show running config. And right now, this is all the default configurations that a white switch would come with. So typically a switch out of the box is going to forward on all interfaces. It's going to put everything in a default VLAN. And it's usually going to actually have a spanning tree enabled by default. So you could, even connect all these switches together and they're going to forward frames. So right now, let's also just check. Show VLAN. Does this have a VLAN on it? Currently, it does have a VLAN 10. So let's just wipe that real quick. It does have that VLAN 10 already. So to completely wipe a switch, del VLAN.dat. There's a data file that's there that's kind of persistent sometimes. And then write erase, confirm, and we are going to reload. The reason that it has that is because my OBS had frozen on capture, so I was kind of partly way through when I realized, like, wait, there's nothing moving on that on that capture preview. So this takes just a second, but it's good to kind of see how you clear out and wipe a device. So let's do a show VLAN, and yeah, so we show no VLANs on there whatsoever. So this is a wiped switch, and just to verify again, pings. It's going to take a little bit because again that network's got to converge a little bit. So we see it can reach .20. Or it's going to be able to reach .20. It's just going to take a bit for that convergence to happen. So usually what ends up happening is it's got to do like essentially a ARP, has to send a ARP request, ARP reply. That switch has got to kind of come up, start forwarding this frame. So there it goes. That .20 is good. And let's see, .30. Yep, since our network is now kind of converged, we are good. So we're receiving pings on both of these devices. So we are good. We are at a great starting point. Let's go ahead and get the switch configured. So jump into configuration mode, comp T, and let's go ahead and create those VLANs. So create a VLAN. Again, if we go back to the PowerPoint, super easy commands. VLAN, VLAN number, and then VLAN name, and then you can kind of, there's a few other parameters that you can add in if you'd like, but for now we're going to keep it very simple. Let me make sure this didn't freeze. Nope, we are good. So VLAN 10, name red, exits, VLAN 20, name blue, end, and if we do a show VLAN, we show right at the top, VLAN 10 and 20 show up right there. They've been created, but we show that no interfaces have been put under those VLANs, and then over here in the data at the bottom, we show that they're created there as well. And we're good to go. So let's jump back to configuration mode. So again, as we put these interfaces into those VLANs, super easy commands. So interface fast Ethernet 0/2 because again we want to put the second one, which is FA123. We want to put that second one into VLAN 10. So we're going to do switch port mode access to statically configure that as a access interface, and then switch port access VLAN 10. So let's go ahead and exit, and then let's do interface fast Ethernet 0/3, and then let's do switch port access VLAN 20 and switch port mode access. Exit, exit. So since this is the first video we've done where we've done a couple of configurations on the switch, let's do a show running config, and we can already see if we look at interface 1, it's on the default VLAN default configurations. Interface 02, switch port access VLAN 10, switch port mode access, and then interface 03, switch port mode access, and switch port access VLAN 20. If we do a show VLAN, we now see that both of these VLANs, VLAN 10 red has one interface there, and VLAN 20 blue has one interface there. So let's go back to our default VLAN machine. Can it ping both of those other devices? It cannot. As we can see above, it initially was able to ping, now it cannot. And while that's waiting, let's go up here and then let's do another show command. So another show command that's really good to know is show interfaces status. And right now we can see the ports that we just configured. So port FA01, this is our default VLAN, FA02, VLAN 10, and FA03, VLAN 20. So just for the sake of due diligence, let's hop into this middle computer and let's see if we can ping the other devices. So we see a couple of test pings that we had before. So let's go and ping 192.168.0.10, and we see that can't ping any other device either. So now that these are all on separate VLANs, they cannot ping each other, and that's what a VLAN is for, right? So we want to make sure those networks are all segmented. Now, to jump into something that's a little bit of a preview of things coming forward, let us connect the switch 0 to switch 1 just to see what happens. So we're going to go ahead, this is packet tracer. We can easily connect one thing to another. And let's put a link between both of these. So as we've kind of said before, switches out of the box, so you can connect them to each other. They will cascade, really easily. And unconfigured switches will forward and switch traffic between each other. So let's log into switch 0 and let's see, interface fast Ethernet 04, change state to up. If I run a show CDP neighbor, CDP stands for Cisco Discovery Protocol, I can see that switch that was just connected. So if I double click over here, let me do a enable show CDP neighbors. I can see that switch is connected right now as well. So let's see something. This computer on the far right has a IP 192.168.0.40 on the default VLAN. Both these switches are connected to each other. Let's see if both of our default VLAN devices can ping each other. So I'm going to hop into this computer on the far left, and then we're going to ping 192.168.0.40. And as we would expect, because of what we talked about, these computers connected unconfigured switches on the default VLAN can ping each other, and the caveat is they are correctly configured with static IPs with the same subnet, but by default, it's passing traffic super easily. We didn't configure anything at all. So if I were to hop into the switch 1 and I'm going to show running config, there's literally nothing configured on these interfaces. It just kind of works. So if I do show VLAN, again, there's no VLANs configured. It just works. So let's do this real quick. Let's add VLAN 10 and let's add VLAN 20. So we're going to go do a compt VLAN 10, name red, VLAN 20, name blue, exit, exit. We're going to do a show VLAN, and there they are. We've created those VLANs that we have on the other switch. There's actually a protocol called BTP that you could use if they're in the same domain, and you'd only have to configure things on one device and they would propagate to the others. But just to keep it simple, we're using a hand configured because we only got 2. So let's go ahead and do something else. So I'm going to do show CDP neighbor. So that laptop is connected on 01. So let's go ahead and compt interface fast Ethernet 01, switch port mode access, switch port access VLAN 10. So the thought is, right, and let me change this just to make sure our labeling is consistent. The thought is that if this on the right, this fourth laptop is VLAN 10, it should be able to ping this laptop in the middle, VLAN 10, right? It should, right? So let's go into this laptop over here. These are both on the same VLAN, and let's try to ping 192.168.0.40. And interestingly enough, it does not work. So why would it not work? Well, as it turns out, there's two different kind of links that you could have between two devices. On both of these switches, these are access ports. So an access port is just like what we would use for an end user device, and that's configured to one VLAN and only one VLAN. What you would use between your infrastructure devices, your switches, your routers, is you would use trunk ports. Trunk ports can be used to pass traffic that contains one or more VLANs, or all your VLANs, or you can specify which VLANs you want. But your trunk ports are usually used in your backbone devices where you're going to have multiple VLANs that need to pass traffic. So because these were unconfigured, default VLAN traffic, native VLAN traffic will pass through just fine. So when this fourth laptop and the first laptop were on the default native VLAN, those are passed perfectly. Being that both of these are now on VLAN 10, they're on the non-native VLAN, now all of a sudden that traffic will not flow through. So how do we fix that? Well, we can easily fix that by making this link in the middle, this dotted line, a trunk link. So there's all kinds of different dynamic trunking protocols, which we can kind of get into later. But just to get this traffic flowing, let's just go ahead and statically create this trunk. So we're going to do this real quick. So comp t. So you know how we basically did the switch port mode access. Well, same exact command. So if we do interface fast Ethernet 04, switch port mode, and if you do a question mark, there's three different options. There's access, dynamic, and trunk. So let's go ahead and make that a trunk link. So took that link down, put it back up, and that link is now a trunk. But there's one other step that we need to do to make sure that the traffic can pass. So switch port, trunk, and then there's a couple of different other options. So we can change that native VLAN, and we can also specify what VLANs are allowed on that trunk. So in this case, switch port mode trunk allowed VLAN 10 and 20. We need a comma there, 10 and 20. Just like that. So let's exit, and that trunk is now set. So if I do show interfaces status, we can see that fast Ethernet 04, we have that configured as a trunk, but we can see at a glance how each of our interfaces is set up. So our first laptop is default VLAN 1, our next one is VLAN 10, next one VLAN 20, and that fourth link we have pointing to the switch is a trunk. So you would need to configure that trunk on both sides. Both of those devices need to be aware that they're trunk. Let's go ahead and hop into the switch, and then let's go ahead and do the same exact thing. So I just want to make sure I'm getting the right one, because again, I didn't label the top diagram, so FA02. So let's go comp t. So we're going to do a interface fast Ethernet 02, and we're going to do switch port mode trunk, switch port trunk allowed VLAN 10 and 20. And let's go and exit, and let's just do, real quick, let's take a look at the configurations we just applied. So if you go and you look, this is a good place to kind of see the different kind of configurations that you would use for a trunk and an access interface. So fast Ethernet 01, switch port access VLAN 10, switch port mode access, but then we got our trunk. Interface fast Ethernet 02, switch port trunk allowed VLAN 10 and 20, and then switch port mode trunk. So now that that's all set up, will both of these devices on VLAN 10 and on two different VLANs be able to ping each other and communicate? Well, let's see. Sure enough, they can. And let's go to the other one, just to kind of see that traffic move in the other side. So let's ping 192.168.0.20, and sure enough, that traffic is flowing through. Um, let's also just go to that first switch, show MAC address table, and you can kind of see where the MAC addresses are coming in, what VLAN that they're on, so we can see that traffic going back and forth. Um, yeah, that's how VLANs work. That's how trunks work, and this is a really good visual to be able to see, like, you know, you have your default VLAN, you can configure your VLANs to for every single other device, and how, two switches connected to each other, if you leave them on a default VLAN, it's going to just work. But the moment you introduce trunks, which you're going to see almost pretty much 100% of the time in your production network, um, you need to be able to create a trunk to pass that traffic back and forth. And you can also see where, if you're troubleshooting things, some of the easy things that can happen. Why can't I pass traffic between these two devices? Well, is it configured as a trunk? Or the other thing that happens too is that trunk traffic, or is that VLAN traffic allowed on that specific trunk? So really cool way to kind of visually see, and I think that this demonstrates like why you'd want to like learn a concept and then go into something like packet tracer and to try to essentially play around with it, create different configurations, see if you can break it, and then see if you can kind of fix it again. So that's all I've kind of got today. Appreciate you watching. Thank you for tuning in. Please like, subscribe, comment. This is only really video too, so promise these presentations should hopefully improve as kind of get a good rhythm going. But again, hope you have a great day, and see you all next video.